Ladies and gentlemen, once again, I'm Erisa Wante to take you through online mathematics lectures. I really thank you for listening to me and getting information from my channel. That's so good. Before I start on the new topic we're gonna look at today, I would request all of you to share this information with your friends. I'm trying to build the number of subscribers and also build my channel to reach out to so many people who need this. So help me out as I help you. Remember, this information is free. You only need your MBs or Wi-Fi and then your access. That is it. And I have done this, I have taken out my video because it consumes a lot of data if somebody is using mobile data. So that's why when I use this app, it takes out my video so you can get the part you want and the audio part of it. So ladies and gentlemen, today we want to talk about probability distribution is one, and we are going to discuss discrete random variables. So what's this? This is gonna be our coverage in discrete variables. Okay, we shall discuss probability distributions for discrete random variables. We shall also how to calculate and use the expectation of x, and that's gonna be the mean. We shall see how to calculate and use the expectation of any function of x, but we shall only talk about simple functions of x. How to calculate and use the variance of x, and then lastly we shall discuss the cumulative distribution function. So this is not really a hard part of distributions, and since we have some knowledge of probability, then it's going to be very useful. Okay, now what is a discrete random variable? So what's a discrete random variable? A discrete random variable, okay, is a random variable that has countable values. Okay, it has countable values such as, okay, we want to see which variables are called discrete random variables. Okay, now before I give you the examples, I want you to imagine you are in a group of four people, and someone who comes up and wants to test you for COVID-19. Maybe some of you could be infected. That is the pandemic that is affecting the world today. So you are four, and this guy, doctor, shows up with his testing kits. He wants to test and see if you have COVID-19. Okay, now the result is gonna be random. Okay, either you have or you don't have, we don't know, but it is random. It's not guaranteed that this is having or the other is having. These figures are going to come out randomly. The results will come out randomly. So the doctor might be surprised when none of you is having the virus. Okay, so probability that nobody has COVID in that case becomes zero because no one has the virus. Okay, now we can also have one of you having, or two of you, or three of you, or four. Okay, so if we get x to represent the number of people who are having the virus, then x takes values which are exact. Either no one is having, or one of you is having, or two of you, or three of you, or maximum four because you're in a group of four people. So that kind of variable which takes exact values is what we call a discrete random variable. Let's give some example. such as, okay, the number, oh no, this can't be, such as the number of people who test positive for COVID-19 in a group of 4 people. Okay. The possible values are 0, 1, 2, 3, or 4. Because you are 4, the number of those that test positive cannot exceed 4. But it is gonna be exact values. You can't start it. 2.5 of them tested positive. No, that's impossible because you can't have half a person. Okay, so the other example I can give you here is, okay, the number of females in a group of 3. Okay, the number of females in a group of 3. Okay, in a group of 3. Okay, so the possible values here, the possible values are 0, 1, 2, 3. Okay, the other example I can still give you here about this kind of variable what we are trying to introduce. You know, I'm just giving you examples about discrete random variables. Okay, the number of times you throw a die until you get a 6. Of times throw a die until you get, okay, 6. So this is not a guarantee that you're gonna throw the first time and get a 6, or the second time, or no. Okay, you can even throw it 1,000 times without getting a 6. So this number is infinite. So we shall see the possible values. The possible values are 1, 2, 3, 4. Okay, these values go up to infinity. You know, this is a probability. We can't really guarantee when a 6 appears, but it can appear on the first row, or the first does not appear, but on the second the 6 appears. Or you unlucky, you do it 4, 5 times, 10, 15, and you're not getting. So you keep trying, not until you get a 6. Okay, so that number, we can't bound it. It goes up to, I don't know what number. Okay, so these are examples of discrete random variables. Okay, it takes exact values. You know, it occurs randomly, but it takes exact values. So each of these values a variable takes has a particular probability, and we can look at the probabilities of the different values of the variable. If we bring them together, then we're gonna come up with what we call a probability distribution. So let's discuss this. Probability distribution. So this is what we are going to discuss. Let me put distribution is. So what is a probability distribution? A probability distribution gives the probability of each possible value of the. If we are to understand a probability distribution, let's consider the situation below. So consider this situation. And this is like going to be an example which we're gonna solve by tree diagrams. Then in the end, it will lead us to what we are trying to discuss, the probability distribution. So what is it? By mistake. Okay, 3 faulty fuses are put into a box. A box containing 2 good fuses. The faulty and good fuses become mixed up and are indistinguishable by sight. So you take out 2 fuses from the box. Now the question is, what is the probability that you take no faulty fuses, 1 faulty fuse, 2 faulty fuses? So let's first discuss this. By tree diagrams, we get the probabilities. Then after, we now talk about what we call the probability distribution. And that's the introductory part of discrete random variables we're trying to discuss right now. So this is the situation, okay? The first picking, okay, you can get a faulty fuse or you get one which is good, that's the complement, okay? And if you pick the faulty fuse, okay, you can still end up with a faulty or not faulty, okay? That's the second picking. These are options. You may end up with a faulty or not faulty. Now let us see, what is the chance of picking a faulty fuse? Yeah? They are saying that by mistake, 3 faulty fuses are put into a box containing 2 good fuses. So altogether we have 5, okay? So this is 3 out of 5, and this is 2 out of 5. That's the first picking, okay? Now, if we picked the first faulty, okay, we can go ahead and pick the second faulty. This is gonna be 2 over 4, okay? And this will also be 2 out of 4, okay? What if we picked a good fuse, one which is not faulty? We can still pick a faulty fuse, but this will be 3 out of 4, okay? And this is going to be 1 out of 4, okay? So the question is 1 faulty fuse. If you are to have 1 faulty fuse, let's look at this. By mistake, 3 faulty fuses are put into a box containing 2 good fuses. The faulty and good fuses become mixed up and distinguishable by sight. You take out 2 fuses from the box. What's the probability that you take no faulty fuses? So the first is a P of no faulty fuses. That means that the first is not faulty and the second is not faulty, okay? So this is not faulty. So this is 1, 1. So this is a 2, 2, 2, 2. Okay. So what do we get? Not faulty, not for this is 2 over 5 times 1 out of 4. It's gonna give us 1 out of 10. Okay, that's the probability that we have no faulty fuse. Okay, what about one faulty? P of one faulty, okay, fuse. Let's see, one faulty, okay, one must be faulty. So it is either the probability the first is faulty and the second is not, or it is the probability the first is not faulty, okay, but the second is faulty, okay, F2. So if we are to calculate this probability, the first is faulty and the second is not, what happen is first faulty, the second not faulty. So this is gonna be, okay, 3 over 5 times 2 over 4 plus 2 over 5, okay, the first not faulty and the second times 3 over 4. So you reduce this and work out 3 out of 10. I think you get 6 out of 10. So the answer here is 6 over 10, okay, which you can write as 2 over 5, okay. It's the same thing as 2 over 5. Now, the next one is 2 faulty fuses. 2 faulty, P of 2 faulty fuses will be 3 over 5 times 2 over 4, okay. 3 over 5 times 2 over 4. What do we get? Okay, we end up with the 3 out of 10. Okay, so that is it. We have 1 over 10, we have 6 out of 10, and we have 3 out of 10. Now, what is the intention of discussing this? Okay, we want to form a probability distribution. Okay, we are going to let X be the number of faulty fuses. Let X be the number of faulty fuses. So we have discovered that the probability of X is equal to 0 when we have no faulty fuse is 1 out of 10. Okay, the probability that X equals to 1 is 6 out of 10. Okay, and the probability that X is equal to 2 is 3 out of 10. So we can form a table, okay, that gives us these probabilities. In forming the table, we shall have X, okay, the number, the variable X is represented by a lowercase letter, and then probability of capital X equal to small x, okay. So when we form this table, we start this, the probability distribution, okay, a function that assigns probabilities to the different values of X. So we have 0 has 1 out of 10, 1 is 6 out of 10, and then 2 is 3 out of 10. So this is the probability distribution function for that situation which we have just discussed, where you get faulty fuses and mix them up with the good fuses, and then you can't distinguish by sight. So these are the probabilities when you pick a faulty fuse, okay. When you pick no faulty fuse, then it is only 1 out of 10 chance. 1 is 6 out of 10. Then for 2 faulty, it will be a 3 out of 10. So you have higher chances of picking a 1 faulty fuse, okay. Now, this probability distribution can be represented on a graph, and we can say these are probabilities of capital X equal to small x, okay. And then here we have the variables, the x's, Okay, so these are the variables, the values, the variable text. So you have 1, 0, okay, 1, and then 2. Okay, how do we represent the PDF, the probability distribution function of a discrete random variable? What do? We represent it with the vertical lines. Okay, 0, 1, and 2. For x is equal to 1, so what I will do, I'll multiply here by 1 out of 10. Okay, the maximum is, if this is 1, then this is 2, 3, 4, 5, 6. Much as I'm sketching, the spaces must appear fairly uniform. So this is 1, 2, 3, 4, 5, 6. So for x is equal to 0, I have a vertical line going up to 1. Okay. And for x is equal to 1, it is 6 out of 10. So you get your ruler and draw something which is perfectly vertical. Mine is not coming up, but you communicate this idea to your friends. Okay, so this is x, it must be a vertical line, not bending, but must be vertical. Mine, I'm saying not fairly vertical because I'm using a tablet and a low frequency leather emitting pen. That's why I'm able to write. Okay, without this kind of pen, you can't write. Then x is equal to 2 is only 3, somewhere here. Okay, so that's the PDF of the above situation represented graphically. Okay, so probability distribution function, okay, is the distribution that gives us probability of each possible value of the variable. Okay, so this is the PDF. Okay, and this is the graphical representation of the PDF. Now, what makes this variable a random variable, okay, a discrete random variable, is one thing that we are going to discuss more in our next meeting. But I'll give you some clue about it. The summation of probabilities of x is equal to this for all values of x, okay, must give you 1. What does it mean? If I sum the probabilities for the different values of x, the variable x, then it must give me a 1. When we have that situation, then we say we have a discrete random variable. Okay, so 1 over 10 plus 6 out of 10 plus 3 over 10 is equal to 10 out of 10, which is equal to 1. Okay, therefore we have a discrete random variable. So in our next meeting, ladies and gentlemen, we're gonna discuss this in details. This is really very, very interesting. You are going to enjoy. Feel free to email me a comment. If you need some special help, I can do online tutoring. You can just reach out and I'll be able to help you out. Okay, do not suffer. I have taught mathematics paper 2 for a long time, so I can always help you out. Okay, thank you so much. I wish you the best.